Alright, I'm at Hyalite Creek here right before it exits out of the canyon, and I'm going to focus on Manning's equation and boundary and critical shear stress. Manning's is 1 over Manning roughness times the area times the hydraulic radius to the 2/3 times the square root of slope. The roughness here looks pretty rocky with some algae growth, as you can see, so probably a high end value. The cross-sectional area varies between the riffle section, kind of right there where my finger is, and the pool section, kind of where I'm standing. And so we have a shallow depth and a smaller area at the riffle, and the pool has a deeper depth and a larger area. The low hydraulic radius is the channel flow efficiency, or the ratio of the area to the wetted perimeter. And the riffle section has a smaller ratio than the pools because of increasing area to perimeter, and therefore the pool section has a greater ability to move water because less of it is being affected by the bottom and sides of the channel. The slope of this reach is fairly steep, as you can kind of see. It's hard to tell, but we can tell because we're in a valley right now, or a canyon up in the mountains, and we have a lower order stream, and so we can kind of designate this as a steeper slope. And all of these parameters define Q, or discharge, a volume per time. And this reach, even though it changes depth and shape, we will have the same flow unless another water source adds to it because of the conservation of mass. There's not a lot of water here, but velocities are big because of slope, especially on the riffles. Now we can look at the boundary shear stress, which is controlled by stream depth and slope. In the formula, our depth isn't that deep, but our slope angle, theta, is fairly steep. But this actual weight or force is pretty low because of the depth, and theta values are usually pretty small. The critical shear stress is necessary to mobilize a particle from the bed and is a threshold for entrainment. And the D50 is part of this formula. As you can see, the median size of the sediment of this reach looks pretty large, and so the critical shear stress has to become larger than the boundary shear stress. Since this reach boundary stress is fairly low, the critical stress doesn't need a lot of force to move or entrain sediment. And since the slope is steep and velocities are fast, especially during snowmelt, erosion of the bed rock can be quite significant.